Now, before we get too far into the qualities that we want to put into the architecture, we'd first better figure out which qualities we want, and for that we need to determine which of these selections we can have, or which are more important to the stakeholders. The problem is that the stakeholders are seldom particularly clear about what quality characteristics they want. They're probably aware of one or two, but when you face them with the whole collection, they probably wouldn't be able to say much about, I don't know, for example, modifiability or performance. I mean, they know they want some performance, but they don't quite know what the importance of that is. But the software architecture, regardless of whether you, the software architecture will produce some behavioral characteristics, whether you intend them or not, so you might as well plan for them. And the stakeholders will, where they have some awareness and priorities, it's unlikely that everybody will agree on just what they all are. So the problem becomes one of not only determining what the stakeholders want, but what the relative priorities of them are, so that you can get, basically the maximum good for the maximum number. So the question becomes, where and how can you determine the non-functional qualities? Well, one way of doing it is having a look at the user narratives. This is one of the reasons why you have them. Now, this assumes that you talk to the customer or the stakeholder, and you've got the data you've got. If you could in now go back and talk to the stakeholder again, by all means do so. But assuming that this is not possible, then you have to have a look back through the information you have. And the user stories or user narratives are a fairly good place to start, because they tend to record the context in which the system is going to be used, and from that you can tell a certain amount about the qualities that are necessary. So, for example, there's one there, and this one is taken from a case study somewhere. And Julie is interested in correlating sightings of the Parameles nasuta, which, for those who don't know or not possibly Australian, a Parameles nasuta is a long-nosed bandicoot, which you can see a picture there. It's a small marsupial, about the size of a good-sized rat. Fairly harmless, lives in the bush, but that's what they are. Anyway, Julia is interested in sightings of these animals correlated with bushfires. So she wants to bring up the tracking data for previous years of sightings of the bandicoot and map it or match it against the bushfire data. So that's an example of a usage narrative there, and from that you can possibly derive some of the quality characteristics that are needed in the system. Now, the stakeholders may assign different importance to different architectural qualities. Not so much may, they probably will. I mean, what is important to somebody who owns the system is quite different from somebody who wants to use the system. So what we need to do is to determine which stakeholders are going to be affected by which characteristics of the product, which qualities, and how important each characteristic is to them. Now, if you simply ask a stakeholder which quality they want in the system, the immediate and obvious answer is, I want all of them. Yes, well, that's not very useful, because you can't have all of them. Some of them do contradict, or they compete with each other. So you can maximize one at the cost of some others. And the other problem is, if you want all of them, then the cost of this development will be extraordinarily high. So we need some way of deciding which ones we must have more than ordinary. Now, we're talking about the non-functional characteristics. So these are expressed as quality attributes, and they determine how the software behaves. The architecture deals with identifying, analyzing, and realizing the quality attributes, largely in the execution architecture. Generally, we can't get everything, so we need to sacrifice some things. Now, in the quality narratives, we have a problem. People will frequently say fast or reliable or something like that, but this doesn't tell us what they mean by fast, and it doesn't tell us what they mean by reliable. So the meaning of these qualitative terms have to be brought out in some way. The easiest way and best way to do that is to have some story that illustrates exactly what you mean, that puts some numbers onto it, or the stories I like are the ones where you're trading off different qualities. For example, if I want high maintainability, should that come at the cost of performance? Well, maintainability generally does. So the question there would be, well, would you accept a 30% improvement in maintainability at a 40% cost of performance, or well, the other way around? Would you accept a 30% improvement of performance if it cost you 40% more in the maintenance? Now, in some circumstances, that bargain will be taken. Other circumstances, it won't. So, quality narratives are a pretty good place to start fleshing out just exactly what we mean. Now, in this case here, we have some grand hero from the hunting of the Snark, who took his vorpal sword in hand. 24 hours the maximum foe he sought. So rested by the tum-tum tree, he stood 5 minutes, on average, in thought. Now we've got some measures, now we can do something with that. So a narrative scenario is pretty good at giving the context and the action and some actual measures to these things. Now, I will stress, you do have to ask the customer. You can't simply make it up yourself. It's surprising how often developers have, sometimes for good reasons, sometimes not, gone off and developed something and then presented to the customers only to find that what the qualities that the customers want, value and expect are not what's being delivered. So the general question when you ask a customer, does the system have to be reliable, for example? The answer is yes, because who wants an unreliable system? But the question, the more interesting question is not do you want it to be reliable, but how reliable do you want it to be? And reliable at the cost of what? So let's try some scenarios. Now, if the system was being updated when a call came in, all right, so reliability and availability, we want the system to be available. But we also need to maintain and upgrade the system. So we're doing some maintenance and a call comes in. Now, what do you want to do? How do you handle that scenario? Do you stop your maintenance and reboot the system and deal with the call? Or do you continue your maintenance and deal with the call after? Well, if it happens to be something like an emergency response system, then I'd probably want the system to be available to attend to the emergency, and maintenance is going to have to fit around that. Now, this may mean I have to develop a dual processing system, a failover system, so that I can update one while the other one's, take one offline, update that, bring it up, swap them over, update the other. Or it could mean that if we can't afford that, we're going to have to think of something else. Alright, so to review then, the main architectural qualities that we're looking at are availability, modifiability, performance, testability, usability, security, and increasingly scalability. So the summary for this particular piece is we need to find the qualities. We need to find the non-functional qualities that we need to put into the system architecture. They have to come from the users, and probably the best and easiest way of getting them from the users is to draw them out in a story. Either ask the user to tell you a story about what happens in these circumstances, or you can have a look at the existing user stories and try to derive them as best you can. But I do stress, they must come from the stakeholders. They can't come from you.